Good timing, my friends. I was just about to jump into into the lesson all by myself. But seeing as I'm not alone, are there any questions from, where was it? Page 219, 220?
Yeah. Question 4 and 5, and also 9 too.
4, 5, and 9?
Yeah.
4, 5, and 9. Okay, number 4. Okay, so it's similar questions we had with the example in the beginning. There's a house, and then the fence is up against it. It's a garden, 120 meters, so the perimeter equals 120 meters. What dimensions would give him the maximum area? What is the maximum area? All right, so we have width, length, width. So we know that 2W plus L equals 120. We also know that L equals 120 minus 2W. We know the area is length times width. And this is the max area that we want, length times width. If we can substitute this in for L, 120 minus 2W, 120 minus 2W times W. That equals 120W minus 2W squared. Switch this around, negative 2W squared plus 120W. Is that the hardest part of the question? Basically, what I'm asking is, do you need me to keep going? Because from here, it's just kind of completing the square.
Yeah, I was just confused about like how to get there.
Yeah, probably the hardest part is right here. Is once you can kind of see this, make so we can only work with like one variable. This way, we're only working with W's. The area is length times width. Well, this equals the length, so I can put that in for the L, and then the W is right there, and then we're off to the races. Are we good if we leave it there?
Yeah, that's fine.
I can keep. I don't mind keep going, but I think you can probably do it from here.
Well, I guess yeah, I might as well just do it then.
Okay. So let's complete the square. Take out that negative 2. Wow, my office is a furnace all of a sudden. Minus 60W. Negative 2W squared minus 60W. So 60 divided by 2 is 30, negative 30. Squared, negative 30 squared is plus 900. We've added negative 1800 here, so we have to subtract, or sorry, we have to add 1800 to balance it. It's negative, yeah, which equals negative 2W minus 30 squared plus 1800. Our vertex is 30 and 1800. This is the width. This is the area. If this is the width, remember 2W plus L equals 120. If W equals 30, that's 60 plus L equals 120. So L has to be 60 as well. So the width equals 30, length equals 60, 30 times 60, 1800 for our area. Probably in meters. Where are we? Yeah, meters. Does that make sense?
Yeah.
You okay with that? Anybody else that's part of the call here?
Yeah, so to find the length, you just divided the area by the width?
Yep.
Okay.
Yep. Just kind of solve. Well, honestly, you could do it that way. What I did, I don't know where to put this chat window because I feel like it's going to block somebody somewhere somehow. You could do that totally, Nathan. But what I did is I just put it into here. Either one works.
Okay.
Okay. Because we know that this is going to be the area. Okay, to number 5, I'm going to go. Unless anybody else has questions. I am recording, right? Yep. All right, number 5. The sum of the measures of the base and altitude of a triangle is 20. Altitude, I'm going to say height. The sum of the base and height, so B plus H equals 20. With a triangle, the area, base times height divided by 2 equals the area. I'm just throwing that out before I read anything else. A, what is the measure of the base that would give the maximum area? Remember that the area of a triangle is equal to 1/2 the okay, so it's just reminding us. All right, we have all that we need right here. We can make, put these in terms of B, or in terms of H, doesn't matter. So I can say B equals 20 minus H, or I can say H equals 20 minus B, doesn't matter. This is the one I wrote first, so that's what I'm gonna do. So if we put it into here, I'm gonna rewrite this 1/2 times BH. That's the same thing. I haven't changed anything, I've just changed the way it looks. Now I'm gonna substitute 20 minus H in for B. So it's 1/2 times 20 minus H times H. That equals, there we go, I put that on the other side. I'm gonna simplify this a little bit, so it's 1/2 times 20H minus H squared. I'll put it over here, that just makes me more comfortable. I don't know where the chat window is for you guys. Simplify more, 1/2 negative H squared plus 20H. I'm doing like all the steps here just so I don't kind of lose anybody. This is all fine except for the negative, so I'm going to take the negative out. So it's negative 1/2, which means now we know that it's this kind of a shape. Negative 1/2 H squared minus 20H, and then we go to completing the square. Stop there for a second, let that sink in, and see if you need me to continue.
Why did you change the half to a negative?
Because I wanted to complete the square, and I want to get the negative away from that H squared. If in working this out, it was like 5H squared, I would have taken the 5 out. It just happens it's like a -1. Is that okay?
Yeah, that's good.
Do you want me to keep going?
Yeah, sure, I guess.
So I'm going to complete the square. Negative 20 divided by 2 is -10. Negative 10 squared is positive 100. Negative 1/2 times 100 is -50. So I have to add 50. Negative 1/2 H minus 10 squared plus 50. Our vertex is now 10 and 50. So if 10 is our height, 50 is our area, we know that B plus H equals 20. If H is 10, then B has to equal 10 as well. So H equals 10, B equals 10, area equals 50. What is the units? Doesn't even say, so we'll just say units squared. 10 times 10 is 100 divided by 2, because that's the formula for a triangle. Gives us our answer. Can you dig it? Any questions? Just going to move my little chat window somewhere else, just in case it helps. Any questions? All right. Let's go to number 9. Oh, it was 9, right? 4, 5, and 9. Is that right?
Yeah.
I already recycled the paper. Okay, the number N of units of a product that is sold at a price P is given by N equals negative 0.2 P. 0.2 is 1/5 plus 30. So N is our Y, P is our X, N is the number of units, P is the price. So the higher the price, the less profit, the less you're going to sell. The lower the price, the more that you'll sell. The revenue is the product of selling price and the number of units sold. What is the maximum revenue for the project? Okay, or product. So this, again, we complete the square. N equals, I'm going to factor out that negative 0.2. I wish it was a fraction, could write it as a fraction. So 30 divided by negative 0.2. Oh, hang on a second. This isn't a square question. The number N of units of a product. Oh, this one's different. This is not a, this one threw me for a second. This is not a quadratic question. Well, I kind of, forget about this for a second. I kind of want to graph this. This is interesting to me. P is 0, N is 30. And P is the price. The revenue is the product and the number of units sold. Well, that seems like that's the highest number, right? Because as soon as we add anything, so let's say, I'll just say 5. So when this is 5 times negative 0.2 is going to be negative 1. Negative 1 plus 30 is 29. So it's just going to go down. Was there a mistake in the textbook? Should there have been a squared in here somewhere? What is the maximum revenue for the product? What is the answer for this? This is weird to me. Do you know what the answer is off the top of your head there, Evan? Did you have it written down? Or am I just, is my brain?
No.
Okay, hang on. I feel like this might be an error in the textbook, unless my brain is just, where are we? This is 7.2. 7.2, this is number 9. Maximum revenue is 1125. B 70. What is the selling price? Maybe I'm not reading the question properly. The number N of units of a product is sold, the price P is given by this. That's the number. The revenue is the product of the selling price. And
I
the
think
number.
they did mess up because if you put the answer of B into the equation, well, I guess 15 times 75. I guess it does work, but it just looks weird.
The number N of units. Right away, I thought there was a typo when it says N of units, because normally you would just say the number N units of units of product. So that's the number. They're going to sell it depending on the price. That totally makes sense. The revenue is the product of the selling price. PN. Oh, you know what? It says the revenue, so we'll just say capital R equals the product of the selling price, so P, and the number of units sold, N. Okay, so this is trickier. I'm misreading it. So it says the revenue is the product of the selling price. Oh yeah, okay, so the product, so this is P is the selling price, and the number of units sold, N. Okay, so the revenue is P times N. So what we need to do is we need to isolate n equals this. So we can put this in for n here. Do you know what I mean? So we have p times negative 0.2 p plus 30. There we go. Just take some reading skills that I teach math, so I need to learn to read better. Does that make sense what I'm doing here? I need to slow down. Oh, we have a chat thing. Let me just see what's going on. The revenues of product. Yeah, that's what, yeah. Thank you, Success. I should have looked sooner. I didn't notice. Success had it. So then simplify this, negative 0.2 p squared plus 30p. So now we've got our quadratic formula. Does everybody see how I did this? Success knows. Are there any questions or problems? I was just going too quick, which is my number one weakness. Is everybody okay with this? Questions? Are you not sure still? Or do I keep going? Okay, I can keep going. Factor that out, negative 0.2 p squared minus, so 30 minus that, or 30 divided by this is 150, is that right? 0.2, so it'd be 330, yeah, okay. So factor that out, and now we complete the square, negative 0.2 p squared minus 150p. Half of this is 75. 75 squared, I think we all know off the top of our head, is 5,625. 5,625. We need to counter that, so that's a negative. So we're going to add whatever 0.2 of 5,625 is times 0.2, 1125. Well, that was an interesting question. Threw me for a second. My weakness as a human being shows me right away. I'm looking to blame the textbook. Bad habit. It's like when people say, oh, this is stupid. Well, it's not stupid. It's often that, you know, we just don't get it. So we want to knock something else. And I just demonstrated that for you. So our vertex is 75 and 1125, which means this is the revenue. P is the price. So whatever things they are, we're selling them for 75 bucks each. So the price is $75. The revenue is $11.25. What is the maximum revenue for this product? Okay, so that's A. What is the selling price? Well, that's 75. And how many units must be sold to achieve this maximum? Well, we can go right back into here, put 75 here and solve for N. So 0.2 times 75, negative 75, we need a negative sign in there, is negative 15 plus 30, 15. So N, so the number of units to sell is 15. That was a tricky question. For what it's worth, I don't see myself giving you something this tricky. If that takes any of the edge off. Any questions? All right, we're going to go to the lesson.
Could you do 7 as well?
Yep. Yes, I can.
I was just getting confused about the maximum area of it.
Sure. The perimeter of rectangle, okay, so P equals 22. Rectangle, I assume, will have width and a length. What are its dimensions if it has a maximum area? Okay, so basically, what it's saying is, so P equals 22, perimeter is 2W plus 2L. 22 equals 2W plus 2L. We can divide everything by 2 and say 11 equals W plus L. And we're looking at what maximum area? Yeah. Area, remember, so area equals length times width. So now we just need to isolate one of these. Doesn't matter which one. I'm gonna, I'll isolate the L. So L equals 11 minus W. So then for our area, where the L is, we put 11 minus W, and where the W is, we put W. And then we go from there. 11W minus W squared, negative W squared plus 11W, and then we move on. Do you want me to keep going with this?
Yeah.
So we complete the square, W squared minus 11W. This is going to be unfortunate. It's an odd number, negative W squared minus 11W. 11 divided by 2 is 11 over 2. 11 over 2 squared is 121 over 4. You know, that common fraction. So we've just subtracted 121 over 4, so we need to add 121 over 4. Negative W minus 11 over 4 squared plus 121 over 4. I hope I didn't make a mistake because this is a goofy looking series here. So our vertex is 11 over 4 and 121 over 4. So our maximum area is 121 over 4, which is, I don't know, I don't trust my brain on that one. 121 divided by 4 is 30.25. That'll be our area.
Okay.
And then the width is, you know, whatever that is, 11 divided by 4. It's 2.75, which isn't awesome. You know, as far as like we intrinsically appreciate and prefer whole numbers and stuff, but it's not always how the world works.
The answer I got in the answer key said 5.5. I think when you were getting the root of 121 over 4, did you
Oh,
forget?
it's 11 over 2. Yeah, sorry. Right, because it's, yeah, that was my mistake, right?
Yeah.
Yeah,
I
sorry for
messed up
that.
on the other,
I'm sorry?
I just messed up on the other part.
Oh, okay, but you're good now?
Yeah.
Anybody else? Questions? I need to open my office before I melt. Supposed to meet with Mrs. Janenga in 5 minutes. Guess what meeting is not happening? All right, let's get into the lesson. The good news is I think this stuff is pretty straightforward. Honestly, I think after that, like those word problems, I think it's downhill from here. All right. So there's that. And if you could give me a thumbs up when you're done copying it. Pretty please. .3 has like 4 mini lessons. So I split it up into 2 groups, 7.3A and then 7.3B.
Is that supposed to say the roots and the zeros?
Nope. The reason I wrote it like this is because they're all equivalent. The
Okay.
roots, our zeros, our solutions, all those words are interchangeable.
Okay.
Yeah, thank you for asking. The roots are the zeros are the solutions. So whatever x equals to make y equal 0. Whether you do it graphically, algebraically, however you do it, it's the same thing. Remember, if you ever want to kind of change how the notes you're copying down, please make it make sense to you. Like that first point, you could just write roots equals zeros equals solutions if you want. Like it's all however you want to equate them. Whatever makes the most sense to you. Just don't let laziness be a factor. I'm only saying that because that's kind of how my brain works. What is the easiest way to get through this? Easiest isn't always best. And when I say me, I mean Mr. Enns. Thank you, Evan. Thank you, Nathan. Thank you, Matthew. Thank you, Success. All right. When a function is in square form, we can see the vertex. Okay, that's nothing new. We can see if it opens up or down, and that this will tell us how many solutions there are. This will tell us basically how many times it crosses the x-axis. We'll see this visually in a second. But if we have, let's say I think I can draw on here. Let me see, because I did it by accident before. Can I make this bigger? Oh, it's blue. That won't show up. I'm just gonna make it black. So let's say, I don't know if this is gonna work. Okay, this is an axis. And if we have a parabola like this, so this is the vertex, it'll tell us, let's say it's like 4 and 1, it'll tell us that it's up in this quadrant. We'll know that it's positive, and we'll know there are no solutions, there are no zeros. This does not cross the x-axis. If we have one like this axis would keep going. We have 2 solutions. When it says a double root, or next year you'll call it a multiplicity of 2, this would be something like x minus 5 squared. And I'll show you what that looks like in action. But basically, even though it's kind of the vertex is right on the point here, or right on the axis, it's a double root. It kind of has 2 answers, but they're the same. Hopefully it'll make sense in a couple seconds when we're gonna have a look at examples. Any questions right now? All right, examples 1 and 2, page 221. So page 221, numero uno says, oops, I got the box in front here. For those of you saying, yeah, well, the chat window, whatever. Well, you know, if you come to class, get the live version, you can avoid it. Anyways, 221, 1A says, put this in square form. Can you tell if it has 1, 2, or no real roots just by looking at the equation? So y equals, we're given y equals 3x squared minus 18x, 3x squared minus 18x. So we put this bad boy into square form, take out the 3, becomes x squared minus 6x. Then we complete the square, x squared minus 6x, 6 divided by 2 is 3, 3 squared is 9. We've added 27, so we subtract 27. 3 times x minus 3 squared minus 27. Our vertex is 3 and negative 27. For those of you copying, I'll give you a few moments to copy that down. We know that this is positive, so it opens up. And then the vertex, 3, 1, 2, 3, and negative 27, somewhere down here. Doesn't the specifics don't matter. All that we know is this opens up, so it's going to give us 2 solutions right there and right there, whatever those values are. When we solve by factoring, right now we're just kind of looking. This is solving by inspection. But when we factor, it'll tell us exactly what those are, and you'll see that right away. Any questions? Part B. Oh, go ahead.
The textbook says it will intersect the y-axis at 2 locations. Is that right?
X-axis. X. That's an obvious mistake. That one I don't have to look up or anything. That's terrible. Okay. It should say x-axis. Feel free to write it in your book. The x-axis into locations. Holy moly. I should be keeping track of all the mistakes in the book and send it in. And get like a free hot dog or something, but I'm vegetarian. So here we're going to factor this. Just going to find the vertex and figure out how many solutions it has. X squared plus, oh, is it just -6? This is what happens when you go too fast. Y equals negative x squared -6. Okay, so to put this into square form, we just have to kind of see, let's put it in a different color. Remember square form, y equals a x minus h squared plus k. In this case, the h is 0, so it's negative x minus 0 squared minus 6. Our vertex is 0 and -6. I was going too fast again. I thought there was a 6x. Our vertex is 0 and -6. 0 and -6 is right here, and it opens down because it's negative. No solutions. No solutions, no real roots. You could say it's an empty set. Lots of different ways to say this. Any questions about that one? Seeing none. Can I change the page? Question, example number 2, just wants you to look at it. It says, what are the roots of the following 2 quadratic functions that are graphed below? Basically, where is it intersecting? Here, it's at sticky note. I have a drawer full of sticky notes. Pens. I'm always offering you guys graph paper if you ever need a pen. Goodness gracious, I've got a billion. Okay, so here, where is it intersecting? It's intersecting at -3, x equals -3 and +1. Those are the solutions. If you punch -3 into the original formula for this, or +1, sorry. Yeah, no, that's right. If you punch in -3 or +1 into this, then y will equal 0. The way this looks, not including the a, y equals x plus 3, x minus 1. So when you put 1 in, 1 minus 1 is 0. 0 times this is 0. Y would equal 0. Doesn't matter what the a value is. So another way of looking at this formula would be x squared plus 2x minus 3. I don't know what the a is, but we could solve for it, but we don't need to. We just don't need to. Any questions about that? Does that make sense?
So how would you write your answer? Would you just write the thing you had on top or in the middle?
Yeah, I'm just giving you all the kind of background. Yep, this is it. What are the roots? The roots are -3 and +1.
Okay.
And then for here, look at this arrow. Missed the spot. It's trying to say the coordinates of that point are 1/2 and 0. This is a double root. So this y equals, or not y, x equals, our solution here would be 1/2 and 1/2. Honestly, if you just put 1/2 once, I'd be okay with that. But you should say somewhere it's a double root. Because this, the reason I'm kind of doing all this work here, is because how I showed you this, how it works out. So for this one, y equals whatever a is, x minus 1/2, x minus 1/2. That would be the formula for this quadratic function. Another way of looking at it, y equals a, whatever a is, x minus 1/2 squared. I don't know if I mentioned it already, but next year this would be y has 0 at x equals 1/2 multiplicity of 2 is the language of next year. Are we okay with this? What does the book say? 1 double root of a half. Questions? We're halfway through the lesson. Okay, seeing no questions, let's move on. Factoring is the other way to solve, and I've hinted at that lots kind of with what we were just talking about. So there is, if you like, I didn't write it down, but there is factoring review. Maybe I'll put it right in the notes. If you need the review, page 224, 225, page 224, 225 is factoring review. Oh, I don't even have the thing up, so I don't know who's done note taking. Okay, I'm ready for your thumbs up if you're done, or when you're done. Thank you, Matthew. Thank you, Nathan. Thank you, Evan. Thank you, success. Let's just get to the examples. All right. Move this, my little chat window or whatever over. Look how red that is. Examples, where are we starting? Page 226. Okay, page 226, numero uno. X squared minus 25. X squared minus 25 equals 0. We factor this. This is a difference of squares. X minus 5, x plus 5 equals 0. That means when x, in this case, when x equals 5, 5 minus 5, that equals 0. 0 times whatever this is 0. That would work. So x equals 5 or negative 5. That's it. Done. You can check, you can check just by looking. When the original equation is more complicated, then you can, substitute and check, but this you can just see. Stop me if this is too fast. I imagine this is straightforward right now. Harder example, x squared minus 11x minus 12. Factor this however you want, whatever kind of style works for you. For me, there's no number in front here, so I can just, I'm just going to put x's. I know both negative signs. I mean, one is negative, one is positive. Now I have to think of the factors of 12. that have a difference of 11. A negative 11, that's going to be 12 and 1. Negative 12 and positive 1. Negative 12 times positive 1, that's going to be my negative 12. But then I do positive x minus 12x, that's going to equal negative 11x. So I know my factoring's right. And my solutions are 12 and negative 1. These are where the quadratic, the graph would cross over the x-axis at x equals 12 and x equals negative 1. That's where the zeros would be graphically.
So are you trying to make the in each bracket to equal 0?
Exactly. Yep. Exactly. 100%. That's exactly what this is with factoring and solving. Third example, 3x squared plus 5x minus 2 equals 0. Move my chat window again. I keep calling it a chat window. I don't know what it is. It's not a chat window. Here, factoring is a little bit trickier. If you want to do that kind of longer way where you do 3 times negative 2 and so on and so forth, you can. You don't really need to because we have prime numbers here. So it's going to be 3x and x, or if you want to do x and 3x, that's fine. The signs are different, so they're going to be different in here. But I can't just plug them in now because it depends. That 2 might go here, that 2 might go there. Looks like it's going to go here because 3 times 2 is 6, and then 6 minus 1 will be 5. This is going to be positive. 3 times 2, positive 6x. And then negative 1 times x would be negative x. So 6 minus 1 will be 5. So this is it factored. And then again, so here, this one here is kind of easy. X equals negative 2. That's going to make it 0. Some of you might not be able to see this one right away, which is totally fine. You will eventually. If you don't see it right away, you can set it up to say 3x minus 1 equals 0, and then just solve for x. Add 1 to both sides, 3x equals 1. Divide both sides by 3, x equals 1/3. So these are our 2 solutions. Our 2 roots, our 2 zeros. Questions about that? Okay, now there's one kind of little bit trickier way of factoring, which is the next little set of examples. Ignore that fa. I was going to make a note and I changed my mind. Factoring review. So this is page 227. This is a square root property. So if I say x squared equals 36, I want to solve for x. I take the root of both sides. X equals, so it's the root of 36 plus or minus. Remember that plus or minus. X equals plus 6 or negative 6. Because positive 6 squared is 36, negative 6 squared is 36. So as long as you remember positive or negative when you root, then you're good. I'm going to not do every single example. I'm going to jump to number 3. We've got 2x minus 3, 2x minus 3 squared equals 49. Am I going too fast? Are we okay right now? All right. I'm going to get the square root of both sides. We just drop this, so it's 2x minus 3 equals plus or minus the root of 49. The root of 49 is 7. So 2x minus 3 equals plus or minus 7. So we kind of go into two different ways here. If we do it with plus 7 or negative 7. I'm going to do positive first. So let's say 2x minus 3 equals positive 7. Oops. And then I just solve. Add 3 to both sides. 2x equals 10. Divide both sides by 2. X equals 5. That's one answer. If I do, move this again. 2x minus 3 equals -7. Add 3 to both sides, 2x equals -4. Divide both sides by 2, x equals -2. And this is where it'd be a decent idea to check. So we have the solutions of 5 and -2. If I put 5 in here, 2 times 5 is 10, 10 minus 3 is 7, 7 squared, 49. That one works. What about -2? 2 times -2 is -4. -4 minus 3 is -7. -7 squared, 49. Cool, cool, cool. I'm going to do one more example just to show you what some of the ugly ones look like. Any questions for this? Anybody still copying? Still need this? One more example. You can come in if you like. Just doing one more example. Sorry to be late. You guys are good with this? Hope so. All right, last example. Number 5. I'll move my little window thingy so it doesn't block you. 3x minus 2 squared equals 5. 3x minus 2 squared equals 5. Notice we don't have a nice, perfect, pretty little square root here, but we still got to use it. 3x minus 2 equals plus or minus the root of 5. So again, we can kind of branch off with positive root 5 or negative root 5, and it's just going to be there. It's just going to hang around because there's not much we can do with that. So if we go one way, let's start with positive 5. 3x minus 2 equals positive root 5. It's redundant. I'm going to add 2 to both sides. 3x equals root 5 plus 2. That's all you can do. You can't make it any fancier, nicer, or prettier than that. Divide both sides by 3. X equals root 5 plus 2 over 3. Done. That's all you can do. For the positive root 5. Now, some of you might say, can I say 2 plus root 5? Sure, the order of that doesn't matter. So now if we go the other way, 3x minus 2 equals negative root 5. We're going to add 2 to both sides. 3x equals, and so now for me, it looks better like this instead of -5 plus root 2 or plus 2. Negative root 5 plus 2. Same thing though. You could do it the other way if you want. Divide both sides by 3. X equals 2 minus root of 5 over 3. Donezo. That's it. That is it. Questions? And you can still, maybe we should check just so you can see what that looks like. Because it still works. It's just grody. So 3x minus 2, let's check this. Check. 3 times root of 5 plus 2 over 3. Nice thing, those 3's cancel. Minus 2 squared equals 5. Does it? Those cancel. So now I've got root of 5. Well, I don't need to write it that small. Root of 5 plus 2. Plus 2? Wow. Use a pencil. Root of 5 plus 2 minus 2 squared equals 5. These cancel. Positive 2, negative 2, so it's just the root of 5 squared. Root of 5 squared is 5. And it'll work the same way with the other one. Questions? So quiet.
You have to check every time.
You should. I think sometimes if it doesn't say, here's the pros and cons. The bad side of it, takes some time, takes some work. The good side, you know if you got it right. Some questions will say solve, some will say solve and check. If it says solve and check, then you have to. If it doesn't,
Okay.
you probably still should, just for your own kind of well-being. Any other questions? That's all I got for you, friends. See you tomorrow. Yong.